Hello and welcome back. Today we'll do another very interesting question. It's called valid anagram and it's on lead code at number 242. So let's quickly jump into the question first. Just give me a second. I'll change the brightness. Yeah. So the question states that given two strings S and T, return true if T is an anagram of S and false otherwise. So what is anagram? An anagram is a word or phrase formed by rearranging the letters of a different word or phrase using all original letters exactly once. So let's quickly get into it. It's number 242. So what is valid anagram? For example, if I have a word beauty. So if I rearrange its letter, it could be meaningful, non-meaningful, does not matter. If I rearrange this, what are the letters? One second, what happened? Yeah. So the letters are B, E, A, U, T, Y, right? If I rearrange and say U, A, E, B, T, Y, these two are anagrams because this is made using all the letters present in it. But all the letters were used exactly once. Like all letters present in it were there. Similarly, say apple. So apple has A, P, P, L, E. So if I say papple, so P, A, P, L, E. These are valid anagrams. But if I said apple and let's say if I said pale, so it has P, it has A, it has L, it has E, but one P is missing. So this is not a valid anagram. Pale is not a valid anagram. Papal is a valid anagram. So similarly, it says that we have been given two strings. One is S and one is T, and we have to return if string S. What happened with this thing? We have to return if string S. I think there is some network issue going on. If these two are valid anagrams, right? So it's fixed. Seems like if these two are valid anagrams. So what we can do is first of all, let's take two valid anagrams. Say cat, S string S is cat, and string T is tack. What we can do is we can take one character from this, say C, and then check the whole string if it is present. Yes, C is present. And then mark off this character. Like now we are working with TA. Then we take A, we see that A is there, and now we're working only with T. Then we take T and we see T is there. So this requires iterating through both the strings in a loop, and it will take O of n square of time, right? Now, very interestingly, if we go towards a very optimal solution, we know the English alphabet only has 26 letters, right? So the number of letters in each word is fixed. Suppose we take a 26 parter array. It's not 26, so A, B, C, dot, 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 till X, Y, Z, right? And this is our array. And we have numbered this array some like something. So 0, 1, 2, and as indexing goes, it will be 22, 20, no, sorry, 23, 24, and 25, since it's zero-based indexing. So when you take cat, what if we already initialize this whole array with zeros, right? And only for those ones, for C, A, and T, only for those indexes. So we'll know those indexes, right? We'll know those indexes. Only for those indexes, we'll say that add 1 to those. So this is string S, right? Add 1, add 1, add 1. So it looks like A, B, C, D, something, something, T, somewhere, somewhere, Y, Z. So it looks like 0, sorry. It looks like 1, 0, 1, 0, dot, dot, 1, dot, dot, 0, 0. Now, for string T, what we can do is, for every time we encounter a character, for every time we're encountering a character, we just subtract one from it, from the array. So what happens? Once again, yes. So what happens every time? So we have encountered T, we say minus one to the position at T. A minus one to A, C minus one to C. Now what happens if all characters are present and same? Then the final array would be all zeros because for S, each character has gotten a plus one. For T, each character has gotten a minus one. And if all characters are present and same, the plus ones and minus ones cancel out and it will be zero. Same case as Apple. Let's go ahead and check out Apple. Let's once check out Apple. So for Apple, this is S, and we have taken say string T as Papel, P-A-P-L-E, and these are our values A, P, P, L, E, and this is 1, 2, 3, 4, 5. So initially it's 0. We'll start with string S plus 1. So obviously P is not twice in the array, P is once in the array. So P gets plus 1, again P gets plus 1. So P is now 2, L gets plus 1, E gets plus 1. Right. Now we'll use pink for T. So P gets minus 1. So this is cancelled. A gets minus 1. P again gets minus 1. L gets minus 1. E gets minus 1. So it's 0, 0, 0, 0. Since these are all present and these are valid anagrams, the final array will be 0. The sum of final array is 0. If the sum of, so if we take pale, if we take instead of papel, we took pale, we figured it out. Say we took pale, right? Let me do a different color. Let's say we are taking pale, right? So similarly in apple A, P, P, L, E, but in pale, P, A, L, E. So see, this is 0, this is 1, this is 0, this is 0. So ultimately the array is non-zero. Ultimately the array is non-zero. So enough of the talking. Let's see if we can write it in code and then figure it out like what is happening there. I hope you understood and let's write it in code. So let's check in code if it's working. So we have a wrong answer. Okay. So now this is very, very interesting. So we've set the if sum is 0. Let's go back into our. So what can happen is we'll take this case itself, rat and car. So in case of rat and car, in case of rat and car, A, C, R, T, right? So this is S, this is T. So we say plus 1, T plus 1, R plus 1, minus 1, minus 1, minus 1. So we have something like 0, 0, minus 1, dot, 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 plus 1, 0. When we do sum, it's 0, but these are not anagrams. So instead of checking the sum, we have to check that all elements in this array are 0. So we don't return it like this. We return, say, return all x equal to 0 for x in ARR. Let's see if it works. And it worked beautifully. And we have submitted it. and it will work. Sorry, I was not on the screen. So we say return x equal to 0, all of x equal to 0 for x in ARR. That checks that all elements in the array x are equal to 0. So that is the solution for this. I have not yet made the GitHub repo. I will make it very soon. But yeah, please keep following. Maybe like, share, subscribe, tell it to your friends. If you learn something new, if you want something new, also let me know.